chart, sometimes referred to as a circle graph, is an effective visual aid for data visualization. Its circular form is split into sectors, each of which symbolizes percentages of the whole, a vital tool for data analysis, reporting, and presentations. A circle graph's simple design makes complex information easy to understand and interpret. Circle graphs, which visually represent percentages or proportions, make it easier for users to immediately understand patterns, similarities, and distributions within a dataset. This helps users make well-informed decisions and effectively communicate important insights.
Welcome to today's lesson in the history and significance of the pie chart. Pie charts, also known as circle graphs, have a rich history dating back centuries, and today we'll explore their origins, evolution, and modern applications. The circle graph or pie chart had been a fundamental tool in data visualization for centuries. Its root back traced to the 18th century, with William Playfair recognized as one of its early pioneers. Despite its rudimentary beginnings, the pie chart gained traction in the 19th century, notably through Florence Nightingale's innovative use of polar area diagrams during the Crimean War. Let's delve into the origins of the pie chart, which can be attributed to William Playfair's contribution in the late 1700s. While his early charts were basic by today's standards, they laid the groundwork for graphical representation of statistical data. Florence Nightingale's use of polar areas during the Crimean War propelled the pie chart into popular usage. Her visualization of mortality causes highlighted the importance of sanitation and healthcare reform, showcasing the power of data visualization in conveying complex information. Moving forward, we'll explore how pie charts have become indispensable in various fields, including business, economics, science, and education. Technological advancement have enhanced their sophistication and customizability, enabling clearer and more insightful representation of data.
Circle graphs, also called pie charts, are visual tools used to represent categorical data. They divide a circle into sectors, with each sector representing a specific category or group. The size of each sector corresponds to the proportion or percentage of the whole that category represents. This makes it easy to compare the relative sizes or proportions of different groups within a dataset at a glance. Circle graphs are particularly useful for presenting data in a visual, appealing, and easy to understand format, making them popular in presentations, reports, and analysis. However, it's important to use them appropriately, ensuring the data is suitable for this type of representation and avoiding overcrowding or misinterpretation. Despite their simplicity, when used correctly, circle graphs can provide valuable insights into the distribution of categorical data.
Understand? Let's define some terms. Pie graph. It is a visual representation where data is illustrated in a circular format. A complete circle signifies the entire 100% of a whole, and the segment symbolizes corresponding portion of the whole. Data. It is a collection of facts, figures, or information that can be processed or analyzed. Percentage. It is a ratio expressed as fraction of 100. It is often used to represent a portion of a whole in terms of parts per hundred. Sector. It refers to a distinct part or section within a large entity. It is often used in context of economy or specific industries. Proportion. It is a broader concept referring to a relationship between different parts or components of a whole expressed as a ratio.
The pie or circle graph is one of the popular method which represents the percentage of a total. In making the pie or circle graph, it has a set of simple steps to follow. Step number 1. Understand the data. Before creating the pie graph, always make sure you understand the data to gather sufficient information for easier access in making the pie graph. Step number 2. Select the proper data. Since the pie graph is of common use, in following step number 1, the data should meet the graph's criteria. Step number 3. Calculate percentage or proportions. Determine the percentage or proportions and divide its value of each category by the total sum of all the given values and multiply it by 100 to calculate the percentage. Step number 4. Choose a scale. Determine the scale of your graph, which includes in deciding the units in making the graph. Step number 5. Draw the circle. Start drawing or constructing the circle. To have better results, it is recommended to use a compass or any circular templates. Step number 6. Divide the circle. Input the results of your calculations and divide the circle you've created into sectors or slices. In dividing the sectors, it should be the same to the portion of the whole it represents. Step number 7. Label the sectors or slices. Each sector should be labeled accordingly for easy understanding of the viewer. Step number 8. Add a title. The graph should have a clear and informative title. Step number 9. Use colors or patterns. For each sector, use different shades of color or patterns for the viewers to distinguish each sector. Step number 10. Include a key or legend. Include one if you're using it to make your graph informative, and keep this close to the graph to avoid confusion of the viewers. Step number 11. Review and interpret. Keep in mind to check it for accuracy once you finish creating your circle or pie graph, and analyze it to make calculations of the data.
So for the first sample problem, a total of 150 public health nurses were assigned to do healthcare services in 3 barangays in the province of Danao. Suppose that 48 nurses were assigned to Barangay Lawaan, 68 nurses were stationed in Barangay Ginsay, and 34 nurses were at Barangay Bayabas. It is our task to create a pie graph that shows the percentage of nurses that were stationed to each barangays. Again, the given were 48 nurses in Barangay Lawaan, 68 nurses in Barangay Ginsay, and 34 nurses in Barangay Bayabas.
Thank you, Anne, for that sample problem. First, in order to solve this problem, we must identify the given data presented. In this case, we found out the total amount is 150 nurses, and they were divided into 3 groups. The first group consists 48, the next group consists 68, and the next group, which is the last group, consists of 34 nurses. Thank you, Anne, for the next step is to convert the given data into percent form. In order to do this, we need to divide the given amount with the total amount. The given amount shown is 48. Then the total amount is 150. When we calculate it in our calculator, we get 0.32. We have to multiply it by 100 to make it a percentage. If we repeat the process for the other 2 given amount, 68 and 34, what we get is 45% and 23%. It's time to make the circle graph. Here, I already made the circle graph of this sample problem. Over here, that now we could see that Barangay Bayabas has 22.7% of the circle graph. Barangay Lawaan has 32%, and the last one is Barangay Guinsay with 45.3%. Now, let's move on to the next sample problem.
Good day, everyone. So we have here the sample problem number 2. As part of her clinical rotation, Sarah, a student nurse, was tasked with caring for a patient with severe fever in the different areas. How many babies, teenagers, adults, and elder get admitted to the hospital per day? So create a circle graph to represent their observation of the patient temperature. So Sarah observed the following distribution of patients admitted to the hospital per day based on age groups and their corresponding temperatures. So for the babies, 0 to 2 years old, 15 patients with severe fever, teenagers 13 to 19 years old, 10 patients with severe fever, adults 20 to 64 years old, 20 patients with severe fever, and elderly 65 plus years old is we have the 5 patients with severe fever.
Thank you, Prisha, for that interesting scenario. To answer that problem, we first need to identify the given data. The given data are 15 babies, 10 teenagers, 20 adults, and 5 elderlies. They all have a severe sickness. If you add them all up, it adds up to 50 patients. So that's our total amount. Then afterward, we have to convert the given numbers into percentage form. To do this, we need to put the given amount over the total amount. So for the babies, there's 15 babies and there's a total of 50 patients. If we put that into our calculator, we get 0.3. And then we have to multiply it by 100 to get the percentage form, and we get 30%. With the same application of our calculation before, we have to do it for the three age groups, the teenagers, adults, and elderlies. At the end, we get 20%, 40%, and 10%. So when we put it in a pie chart, it looks like this. 10% are elderlies, 30% are babies, 20% are teenagers, and 40% are adults with severe sickness.
Sample problem number 3. In a pediatric ward, nurses need to track the distribution of different types of childhood illnesses among their patients to ensure effective resource allocation and care planning. Suppose data collected over a month in a pediatric ward reveals the following distribution of childhood illnesses: respiratory infections, 40%, gastrointestinal disorders, 30%, neurological conditions, 20%, and other illnesses, 10%. So create a circle graph to visually represent these proportions. Again, respiratory infections, 40%, gastrointestinal disorders, 30%, neurological conditions, 20%, and other illnesses, 10%.
Thank you, Don, for that wonderful sample problem. In order to answer this problem, we need to identify first the given data. What Don provided us was the 40% respiratory infection, 30% gastrointestinal disorders, 20% neurological conditions, 10% other illnesses. If you add up all of the illness, the percentage, they all add up to 100%. From all of those data, it's time to make a circle graph. Here is the answer to this problem. There's 10% other illnesses, there's 20% neurological conditions, 30% gastrointestinal disorders, and 40% respiratory infections. Thank you.
From the sample problem, the given data is as follows: 48 nurses in Barangay Lawaan, 68 nurses in Barangay Ginsay, and 34 nurses in Barangay Bayabas. The total amount of the data is 150. We were asked to make a pie graph out of the data given. To do that, we first had to turn the data into percentages. So to turn the data into percentages, we first have to divide the given amount to the total amount. So 48 divided by 150 is equal to 0.32. And we multiply that to 100 to make it into a percent. So 0.32 times 100 is equal to 32%. Next, we do that with the other data. So 68 divided by 150 is equal to 0.45 times 100 is equal to 45%. And 34 divided by 150 is equal to 0.23 times 100 is equal to 23%. After turning the data into percentages, we can now turn the data into a pie chart. For the second problem, the given data are as follows: 15 babies, 10 teenagers, 20 adults, and 5 elderlies. The total amount would be 50 patients all in all.
So for the second problem, we were asked to create a circle graph to represent the observation of the patient temperature. But first we have to get the percentages of each of the data. So using the formula from the previous sample problem, we can now turn the data from this problem into percentages. So the babies is 30%, teenagers 20%, adults 40%, and elderly 10%. After converting the data into percentages, we can now turn it into a circle chart, and we can observe that the adults have the biggest slice due to its value being the biggest. For problem number 3, the given data are as follows: respiratory infections 40%, neurologic conditions 20%, gastrointestinal disorders 30%, and other illnesses 10%. And just like with the previous two problems, we were asked to create a circle graph to visually represent these proportions based on the data. But since the given data are already in percentages, we can now go directly to making a circle graph. And here we have the circle graph for problem number 3, and we can observe that respiratory infections has the biggest slice due to it having the highest value, which is 40%.
So in conclusion, circle graphs, or also known as pie charts, are valuable tools for visually representing data, and proportions. They provide a clear and easy to understand way of illustrating the relative sizes of different categories within a dataset. Also, circle graphs are effective for conveying percentages and proportions, making them useful in fields such as business, statistics, and research. And also, when interpreting circle graphs, it is important to ensure that the data is accurately represented and that the chart is effectively labeled and titled for clear understanding. And overall, circle graphs offers a visually compelling method for conveying proportional data and are a valuable asset in data analysis and presentation.
Here are some videos and websites that we use to formulate our presentation.